Okay, let's get going here. Make sure that we got my notes set up and I'm working in an organized fashion. My teaching here is supposed to teach you things that you don't know. That's my goal. I'm not here to give you rote exercises or things like that. I'm going to give you exercises on this math I'm doing now tomorrow, and I hope you're listening carefully. Remember, you can always play the video back, so keep that in the back of your mind. So I'm going to do two problems. The topic here is rounding and precision, and we're going to look at two meanings of the word precise, the mathematical meaning, and then more importantly, I would say, is the scientific meaning of what's going on here. So I'm going to solve this guy here, and we're going to use our new tools that we can work with radicals, and I'll give you an exercise tomorrow and some problems on simplifying them, and we can work this way, taking advantage of the fact that we're doing volumes and get a little high school or getting close to high school work done. So anyway, the task is to compute R. So that seems to be pretty easy for most kids. They're going to say, all right, here we go again. Got the same old thing. We plug in V, and that's 80 pi. Isn't that nice? The pi's are going to go away. And R squared, we don't know that. And H is 4. So I divide by pi. I divide by 4. And when I got everything left, it says 20 equals R squared. Well, we don't stop here. We know that 20 is not a perfect square, but we've been taught to proceed. And when I put the hat on both sides here, I end up with R equals radical 20. Now, the mathematician doesn't stop here, but he or she only takes it one more step, because really, R equals 4 times 5, and no one can deny 4 times 5 doesn't equal 20. I'll separate the radical signs. We can talk more in detail about that later. But aha, 4 is a perfect square. So R, as far as the mathematician is concerned, is 2 radical 5. That's how we say it. And that's some number. I can put it on the calculator. But the person who does math would say, I don't need that. I'm good. If I plug this in here, I'll get back to 80 pi. No problem. And you can work it out yourself. If you square this, you'll get 20, and then 20 times 4 is 80, and there's the pi, and you'll have it perfectly done. All right? So this is precise. This is the mathematical idea of precision. What is exactly radical 5? It's kind of like a figment of our imagination. It's an imaginary representation of this number that never ends. Okay? So that's one way of looking at things, and I'll give you a problem like that on your assignments tomorrow. But now I want to try to tie it in a little better with rounding and precision, and I'm going to change the problem slightly. Okay? I'm going to keep the H equals 4. I want to find R, as before, but now I'm going to say that the volume is 80 cubic units. And this is more of the kind of data that an engineer would work with, right? The engineer wouldn't work in terms of pi. That's nice for equations and solving for R and solving for H, things of that nature. But a person who's working, say, on engineering the finest soup cans ever or whatever, definitely wouldn't be working in terms of pi. So the Common Core wants you to be able to use a calculator and think about things the way they're going to do it. So I'm going to solve this, pause in the middle, and do my little thing about explaining how we're going to do rounding and what we mean by precision. Okay, so let's solve this again. We go V equals pi r squared h. V equals pi r squared 4. And of course, V is 80. Should put it right here. And so I divide by sides by 4, and I get 20 equals pi r squared. Divide both sides by pi. I have to do that because I'm not looking for pi r squared. I'm looking for r. And I divide both sides by pi, and they cancel there. And finally, we have r squared equals 20 over pi. put the square root sign, the hat on both sides, and r equals 20 over pi square root. Oh, this is what engineers work with. This is a number. It's an irrational number because I told you 20 is not a perfect square. And even this number here, before we took the square root, that's not a perfect. That's an irrational number as well. It can't be a rational number because any number attached to an irrational number is automatically irrational. So there's my answer. I'll write it nice and big. R equals radical 20 over pi. And 8th graders should be exposed to stuff like this. This is when you take a course in physics, for example, a circular motion. The pi never goes away. It's inside your equations. So there we go. We have an answer. And for the mathematician, this is precise. This is the answer. This is what I want. But say you need to devise a mechanism with this particular soup can, and you need to know exactly what you're talking about here. So that's where we'll stop here just for a second. We'll keep our answer. I'll give you a problem like that tomorrow that you can do in the assignments. And now I'm going to make a little listing of our digits, make a separation patch here, and these are the 10 digits that must come out when we do irrational numbers. We said they have no pattern, they go on forever, and there we go. This batch here, the first 5, 0, 1, 2, 3, and 4, we agree, gentleman's agreement, that when this decimal comes up, when this digit comes up on the calculator, well, we're going to agree that you stay the same. The digit that you're looking to round stays the same. And then we're going to agree that if it's any one of these upper 5, if this digit comes out with what you're looking for, then the digit goes up one more. It's just splitting things down the middle. It's an agreement. And by the way, it has profound implications that we don't worry about as 8th graders. However, there we go. Just splitting the difference. You guys stay the same. You guys, you go up one. Let's look at a problem here and turn this thing on. And I took the liberty of putting this on the calculator. And now I'm going to write it out as far as the memory of the calculator will allow me. So you should keep in mind, and we talked about this when we studied Pythagoras, that this sequence of digits goes on forever in an unpredictable fashion. So let's say, just for the sake of the argument, you work for NASA, it's part of spacecraft, precision machinery, and you need to know what this is to the millionth. So a millionth, you say, yeah, to a millionth. So let me work on it here and show you the basic ideas so you see that it doesn't matter what they tell you to do. And this would be a tenth, this would be 100th, this would be 1,000th, this would be a 10,000th, this would be 100,000th, and there we go, there's a million. That's the guy we're looking for. And you're taught in 6th grade to take the digit to the right and circle it. That circled digit, you draw a little arrow back here. So this digit that I circled is either in this category or in this category. It can't be anywhere else. We covered all the digits. If it's here, this digit goes up one. If it's here, the digit stays the same. So when the engineer puts his or her calculations into the computer, this would be the answer to a million. This is how it works. And it's always the same. It's never going to change. So, for example, if I take the same number and I want to know what it is to 100th, then again, I just count to the right. There's a tenth. There's 100th. And I take the number out. There we go. And now I'm circling the digit to the right. I draw the arrow here, and in contrast, we see that 3 belongs to this category over here. So rounded to 100, the number here would be 2.52. So with that in mind, we need to be able to do problems like this. I'm going to give you some tomorrow where we'll be expected to, and I'll tell you what to round it to, and you'll use your calculators to put this in here. By the way, these, the square root button is always under the square button. It doesn't matter what calculator it is, all right? So when I got 20 over pi, yellow square button, and you see the, you'll see that your square root will pop up there. And then I write 20, and we're very lucky we have a pi button here, divided not by 3.14, but by the pi button that's on the computer here. And there we go, and that's how I came up with that number. So I'll give you a problem like that tomorrow, and we're starting to see that this is how they want you to use the calculator. You will see it all over the place in that multiple choice test that I'm planning to give you in the foreseeable future. So this is the idea of rounding. This is the idea of precision. They want you to be able to use the calculator and round. So again, to an engineer, this is precise. To a millionth. Can you go farther? Sure you can. To the math person, this is precise. This represents exactly what this irrational number is. I guess in the practical world, you really want this number, right? Especially if you're actually working with real world things. So I'll leave this here, and I want to come right back and propose some problems for you to think about in relation to some of this stuff. Okay.